Okay, let's have fun. For this circuit here, I would advise you to build it up with the circuit builder at FET, which is the website is going to be phet.colorado.edu, and look for under simulations for circuit builder. Okay, I use the default resistance for all light bulbs, which is 10 ohms, but then I changed the voltage of the power source to 75 volts. Okay, those are all identical light bulbs. And the question here, assuming that all resistances are 10 ohms, find the current through each of the branches. Okay, to do that, and I run through several screens doing this, I'm going to try to simplify the circuit. I'm going to try to simplify the circuit by finding components of the circuit that are either in series or in parallel. Now, for parallel, remember the key is that you find a loop that contains only the two devices. We have examples here, like these two. That's the only two in that loop. We also have these two. They are the only two in that loop. So both of these are in parallel. Let's see, is there anything else that's in parallel? I don't see any. Okay, so those two are in parallel, so we can replace them by a resistor. That's the equivalent resistance. And remember, for resistors in parallel, I chose the wrong color, 1 over R parallel is 1 over R1 plus 1 over R2. Now, if those are the same value, then that's twice over R1, and R parallel is just R1 over 2. That makes the math a little easier. So in this case, we have RCD, the parallel, the equivalent to C and D, is going to be RC over 2 or RD over 2, that's going to be 5 ohms. And RIJ is going to be as well 5 ohms since they are in parallel. Okay, and we'll replace these in 1 second. Now we need to also identify what's in series. I'm going to use another color for this. When I have two elements just next to each other, that's easy. We know F and G are in series. A and B are in series. So RAB is going to be R of A plus R of B, so that's going to be 20 ohms. And RFG is going to also be equal to 20 ohms. Now we need to go a little further. Remember the test for series, any loop that includes one resistor should include the other one, for whatever loop we make in the circuit. Let's try E. If I go in a loop around this, if I go this, to go back to E, I still have to go through H. To go back to E, I still have to go through H. To go back to E, I still have to go through H. So RE and RH are in series. And we can also write them. REH is equal to RE plus RH, 20 ohms. Similarly, we can do the same thing. A, B, and K, they are in the same branch. Any loop that includes A, B includes K. So actually R, A, B, K is equal RAB 20 ohms plus 10 ohms, 30 ohms. So this is what I could simplify so far. So if I go to the next screen, I should have here 30 ohms. I should have here for this one 5 ohms. I should have here 20 ohms. And I should have here 5 ohms and here 20 ohms. This is my new circuit. Now, can we simplify this more? Of course. Now we have new configurations. If you look at these two, they are now in parallel. So to find the equivalent resistance, one over R parallel is going to be 1 over 20 plus 1 over 5 ohms. So this is going to be 4 over 20, so it's going to be 20 over 5. So R parallel is 4 ohms. So that's the only simple thing that we can do right now. So I'm going to replace these two by 4 ohms. Remember, this is 20 ohms, and this is 5 ohms, and that's 30 ohms. Okay, now what do we have? These two are now in the same branch, so we can combine them. We combine them, they are in series, so it's 24 ohms. So we have here 24 ohms. Remember, this is 5 ohms, and that's 30 ohms. Now look what we have. These two are in parallel. So 1 over R in parallel is equal to 1 over 5 ohms plus 1 over 24 ohms. 24 ohms. Okay, I'm not sure about an easy common denominator, so I'm going to multiply this one by 24 and this one by 5. So I'm going to have 24 plus 5 over 5 times 24, 5 times 10, 100, and 5 times, so over 120. So RP is going to be 120 over 29 ohms. So now we have 4.13 ohms, 30 ohms, and my voltage source which is 75 volts. Now these two resistors are obviously in series. There is nothing else left in the circuit. So the overall resistance is just 34.13 ohms. Now my current then in the circuit is going to be, in this branch, is going to be 75 ohms over 75 volts over 34.13 ohms. Which is about 2.2 amps. So we know the current here is here out of the positive 2.2 amps. Now we back. Okay, let's see. So this is 2.2 amps. So we backtrack. This is 2.2 amps. That means we here have 2.2 amps, but then now here it is divided. Now remember where these came from. This is 5 ohms, and that one, if we go back a few screens back, 24 ohms. To be able to find the currents through these branches, I need to find the voltages across each of the branches. So I'm going to go back again here. If I have 2.2 amps, and I know this is 4.13 ohms, so now the voltage across it is going to be 4.13 times. So that gives me the voltage here is about 9 volts. If that voltage is about 9 volts, that means that the voltage here is also about 9 volts. That means that the current through the 5 ohm resistor here is going to be 9 volts over 5 ohms. And the current through the 24 ohm resistor is going to be 9 over 24, that's 9 volts over 24 is going to be 0.375 amps. Here we still have the 0.375 amps. But then what are these? Trying to remember what we wrote now before. This is 20 ohm and this is 4 ohms. So the voltage across the 4 ohm is going to be, the voltage from here to here is going to be 4 ohms times 0.375 amps, 5 volts. The voltage across the 20 ohm resistor is going to be 20 ohm times 0.375. I'm not sure we need it yet. I'll go back to it if we need it. So now here we went back to how did we get the 4. We got the 4 through a 20 and a 5. The voltage across each one of them is what we just calculated as 1.5 volts. So the voltage across the 20 is 1.5 volts and the voltage across the 5 is 1.5 volts. 5 is 1.5 volts, meaning the voltage across each one of these is also 1.5 volts. Meaning that the current voltage across J is equal to voltage across I, it's 1.5 volts. Meaning that the current through I is equal to the current through J is going to be VI over 10 ohms. So it's going to be 0.15 amps. Now, the voltage across FG is also 1.5 volts. But then FG is 20 ohms in this case, so the current is going to be IFG is going to be 0.075 amps. Now the current through E is the same as the current through H, is what we found a few screens back, 0.375. Okay, so 0.375 should essentially add up to this one here. 1.5 plus 1.5, that's 0.3. I mean 0.15 plus 0.15, that's 0.3. And then 0.075, that gives us that one. Now for C and D, we have determined a little while back that 0.8 amp. This means that the current here is 1.8 amp. But that's going to be divided by these two resistors, so IC is going to be 0.9 amps and ID is going to be 0.9 amps. And that solves everything.